Hello everybody. Today we're going to be starting chapter 6. We're going to be looking at linear functions. This is very similar to some of the stuff that we learned in the previous chapter, chapter 5, when we looked at relations and functions. We talked about rate of change. So rate of change is equivalent to what we're going to learn here today with the slope. So we'll go back and we'll take a little look at one of the ideas. So what we're doing today is we're going to start with 6.1, it's slope of a line, and we're going to make a connection with rate of change. And what does that slope of a line look like? So you can see slopes you have, you can see them in peaks of roof. They use this to calculate your slope of your roof. It's actually what we call a pitch, is a common word used. So if you're building, a home or a garage, and you want to figure out what your pitch is going to be, it's rise over run. It is slope. And what they use something, a value. Normally the run is 12, and then it's rise. So it's rise over run. So if you want to have a pitch on your house of 10 by 12 for your roof, that means that the run is going to be 12 and the rise is going to be 10. So it's 10 by 12. 10 rise and a run of 12, and that's what your pitch looks like. So this is a common practice that is used in construction of, like I said, even like a home, a garage, or even a barn. Okay? So this is going to be called slope. So slope is equal to the rise over the run. So it's basically how far are you going up or down divided by how far you're going right or left. Obviously up is positive, down is negative, right is positive, left is negative. Okay? So rise is your vertical distance and the run is the corresponding horizontal distance. So if you look at this first roof, they have it broken up with a grid. So this one here has a rise and run of 13 over 13. The second one, roof B here, has a rise of, it's 1, 2, 3, 4, 5, 6, 7, and the run is 12, so 7, 12 here. And then this one is, it's a lot steeper, you can tell, which is 14 over 8. And you'll notice when you calculate it, roof A has a slope of 1. This slope is clearly on the second roof, roof B, clearly is going to be less than the slope of the first roof, which indeed it is, 7/12 or decimal 583 repeated. And then the third roof, you can clearly see that it's the steepest of the three. So if the roof A was 1, this is obviously going to be greater than 1, and indeed it is. It's 12 divided by 8, which is 1.7. Okay? And it just talks about that. So let's do a little reminder of what we learned in chapter 5. We talked about rate of change. We looked at the change in the dependent over the change in independent. I briefly mentioned it's a change in y over the change in x. So y is the rise and x is the run. Again, I've made these connections in the previous chapter, if you do recall. So let's look at the first example here. It says example 1, determine the slope of the line segment. So we're not going to use the rate of change anymore, which it is equivalent, but we're going to use slope, which is equal to rise over run. So we got to figure out what the rise is from A to B. So we're obviously, and we read a graph just like we read a sentence. It's left to right. So point A, we have here, you can clearly see that it's at a y value of -3, and it goes up 1, 2, 3, 4, 5, 6. So that's the rise. And then the run is when we go, after we do the rise, how far right do we go? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And there we are. So the rise and the run. So to answer that again, it's going to be equal to a rise of 6 over a run of 10. And a common practice, what you like to have is you like to put it in simplest form, which is equivalent to 3 over 5, 3/5. A rise of 3 and a run of 5. So up 1, 2, 3, run 1, or right, I should say. We don't say run, we should say right, the direction we're going. Right 1, 2, 3, 4, 5. Up 3, 1, 2, 3, right 5, 1, 2, 3, 4, 5, and there is your slope. We'll do the same in the next example, example 1b. So in this one, we're going to go from point C to D, you're going to notice obviously this is decreasing. The previous one was increasing, so you'll notice it was positive. So in this one, we'll end up with a negative slope because what we're going to do is we're going to go down first, giving us a negative. So we're going to go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we're going to go right 1, 2, 3, 4, 5. So the rise, we still call it rise, but it's negative, so that means it's going to go down. So it's down 10 and right 5, which can be simplified to negative 2. Slope is equal to rise over run, which is negative 10 over 5, which is negative 2. Remember, just to make sure we simplify, like I mentioned earlier, that's really important we do that, okay? So I've just entered in the arrows like I did before, just a summary. So we went up 6, you can see the arrow rise is 6, and we went right 10, so the run is 10. In the second example B, we went down 10, so the rise is negative. Negative represents down, and then we went right 5, so our run is 5 positive. Okay, a couple of check your understanding questions there for you to work on. There are answers, and here they are. Next, what we're going to do is I'm going to go over some of the 4 different cases that you may see for linear lines and their slopes. So we just looked at the increasing positive slope and the decreasing positive slope. They were examples 1A and B. And then there's also 2 other possibilities that occur, and this is sometimes we have a horizontal line, and this has a slope of 0 because you're not going up any or down any, so the rise is 0, and it's over a run. The run is basically, it's 6 for this particular example, but it could be infinite because it could go on forever left and right. So it'd be 0 divided by anything will be 0, right? Divided by a number will be 0. So any horizontal line has a slope of 0, and this will always be true. And then when we look at a vertical, we have what's called an undefined slope. This is a really interesting scenario. So for a vertical slope, the slope is equal to rise over run. So the rise is, in this case, the rise is 6, and the run is 0. It hasn't going left to right any. So this is undefined. Anytime you try to divide by 0, it's undefined. So any vertical line has a slope that is what's called undefined. We'll look at more of the equation and some different aspects later on in the chapter, but those are 2 scenarios, 2 special cases that we want to look at and keep in the back of our mind. Let's look at the next example. It says draw a line segment with a given slope. So I've taken and I've drawn these for you. So I picked R. R is just, you can pick any variable you want. You can use your initials. It doesn't make a difference. So we picked the point R. I put it down here in quadrant 3 because I knew I was going to go up 7 or right 5. So I wouldn't start over here. It doesn't really make sense, right? So I went down here and I started at -2, -3. I went rise of 7, 1, 2, 3, 4, 5, 6, 7. Then I went a run of 5, so I went right 5, 1, 2, 3, 4, 5. Remember, up is positive, right is positive, down is negative, left is negative. So the rise is 7, the run is 5, and then I end up at this point 3 and 4. Do the same thing in the second example, example 2b. It says -3 eighths. Usually we put the negative. We'll use that with the numerator, the rise. It can be either one, but if you put it with the eighth, what you have to do is you'll have to go from right to left. So normally what we always have is we have the negative in the numerator. So most of the time we're always going right, so because the denominator is positive, and we use the numerator as up or down. Just a strategy. Doesn't have to be that way, but going left to right, it'll make sense. So the negative is with the 3, right? Because this is the same as saying it's equal to -3 divided by 8, all right? Now see what the computer likes to put it right in there, but the negative. They're equivalent, right? So we'll pick a point T. This time I was going down and then right, so I use quadrant 2. So I picked the point here at -3, 4. I went down 3, 1, 2, 3, and then I went right 8, 1, 2, 3, 4, 5, 6, 7, 8. and I call this point U. Draw a line segment from T to U, and the slope is -3/8. Now again, sometimes you'll be given a particular point. This is just getting familiar with actually drawing a linear line segment, okay, using its given slope. A couple of examples for you to try. Remember, if using this one, I recommend I start down way down here, because we're doing a run of 9, so we only have 10, so maybe start here or here. And this one is, again, is negative, so again, you're going down. So I'd start up somewhere high here, okay, maybe right here. Again, it doesn't make a difference, and that's why it says the answers will vary, because it's going to depend on where you start. But I definitely recommend starting in quadrant 2 or 3. If it's positive, quadrant 3. If it's negative, quadrant 2. Just a recommendation. So this goes back to the equivalent fractions we did in example 1. You'll see this line, there's a number of different points, right? You got M, N, P, Q, R, S, T. I have 6 slopes that I've found here, right? Or sorry, 3 slopes, and they're all equivalent when you simplify the fractions, right? So TU over UM. So I went T up to U and U over to M, right? So I went up 12, right 18. Right, which simplifies the 2/3. Look at SB, I went up 8, right 12, again simplifies the 2/3. And R, W to P, I went up 4, right 6, again. So picking 6 different points on my graph. And again, you could use a number of different ways here. At the end of the day, they're all equivalent to 2/3, right? Look, you can look up 2, right 3, up 2, right 3, up 2, right 3, up 2, right 3. So they are equivalent. All right, so that's why simplest form is important. Okay. Now we're going to look at, in the next example, we'll stop here. We'll take a quick look at slope of a line, and there's a formula for slope of a line. And I briefly talked about this in chapter 5. I did something similar, but this is a formula that we're going to use for finding slope of a linear line. So we'll get into example 3 in the next video. Thank you, everybody, and we'll talk again soon.